So compound events, now we're looking at things that happen sort of one after another or two separate simple events. And compound events often work with independent events, and sometimes they work with dependent events. So some of the stuff that we're going to be looking at today deals with some dependent events. So here we have 3 boxes, and you're going to pick a box at random, and then you're going to pick a marble at random. So those are the 2 simple events. First a box is chosen, and then a marble is chosen. And with these kind of events, we're often going to draw a tree diagram. So you choose what you're going to do first. First thing you make a decision on is choosing a box, either box 1, box 2, or box 3. And we can put the probabilities on each of those branches, because there's a 1/3 chance in each of them. Then in box 1, you could get a white, a blue, or a red marble. Same thing in box 2, same thing in box 3. The probabilities are different depending on which box you're looking at. So in box 1, there's an 8 out of 16 chance for white, 2 out of 16 for blue, and 6 out of 16 for red. So now looking at the question is saying, what is the probability that the marble selected is red? And so you can see on the tree diagram already, I've highlighted the 3 branches that represent that. You could get a red one out of box 1, box 2, or box 3. So it's like there's 3 different cases. And just like you did cases in previous years, when you're figuring out the probability of red, now you wouldn't have to, this is the proper notation to say what we're going to find out. It would be fine if you just went to the second line here with the numbers. But this is showing I'm figuring out the probability of box 1 and a red one, box 2 and a red one, and box 3 and a red one. And those are independent events. So the chances of getting box 1 and a red one would be the 1/3 times the 6 out of 16. Box 2 would be the 1/3 times the 3 out of 12. And box 3 would be the 1/3 times the 3 out of 12. Now if you type this whole thing into your calculator, you would get approximately 29.2. Question, does everybody know how to get your calculator to tell you it's 7 out of 24? So if we type this all in and got the 0.292, how to turn that decimal back to a fraction? Yes? Good. So anyways, if you type this all in, I'm going to do the shortcut. I'm just going to write 7 out of 24. That gives me my decimal of 0.29166. If you had that decimal, you could hit the math button, and the very first one is fraction, and that'll change it back to that fraction 7 out of 24. The nice thing about answering 7 out of 24 is that's an exact answer. Then you can use your equal sign, and you don't have to worry about 3 sig figs or any of that kind of stuff. You can leave it as a decimal answer, and then you can use your approximation sign. One thing that is new in the last couple of years in the IB program, and it's sort of a safety net. So as far as showing your work, if you went from this to the decimal place, and you made a mistake and just wrote 0.291 instead of rounding it up, they're going to take off a whole mark for that mistake. However, if right before you wrote this, you went approximately 0.291666 and did a bunch more decimal places, if you wrote a bunch of decimals and still made a little mistake in the 3 sig figs, they're being generous now and not taking off that extra mark for the rounding error. Because they can say, you had it right here and it was just a simple mistake, so then they're not going to take off that mark. So as sort of a safety net, if you want to, when you get a decimal answer, write a bunch of them down and then go to your 3 sig figs. That is a nice way of doing that. So there's 3 more examples that are very similar to this. We're going to take about 10 minutes now to work on those. Either you can work in a small group or you can work alone. And then after 10 minutes, we'll go over the answers for those next 3 examples. So for the first one, as far as setting up the tree diagram, notice how this is a little bit different. We're not choosing either box A or box B, whereas in the first one we chose box 1, box 2, or box 3, and then chose a marble. Now we're choosing 1 marble from each box. So your simple events, and I've labeled them here, box A, box B, the first thing we do is choose a marble, say from box A. And then our second event is choosing a marble from box B. We're not choosing box A or box B because we're doing something from each one. So as far as setting our branches up of our tree diagram, here my first set of branches is what I choose as my first simple event. My second set of branches is what I choose as my second simple event. And when we read this question in this one, we're choosing something out of box A and something out of box B. Whereas in the previous example, when we look at this tree diagram, here we were choosing a box and then choosing a marble. So our first thing we had to make a decision on was which box, and then we had to decide which marble. Here, we are picking out of both boxes 1 marble. And so when we go to figure out, find the probability you choose 2 balls of a different color, well, there's the 2 branches there. You could get red and then green, or you could have picked a green one and then a red one. Putting those together, we should get a probability of 1/2. So again, when drawing your tree diagram, each set of branches on your tree diagram represent a different event. So you have to say, well, what is one of the events? And sometimes, like this one, they could have happened simultaneously, but for the probability, you can say, okay, I'm going to do the box A first and box B second. All right, do a quick check, see how you did on this one. There's the tree diagram. Picking a marble first, which at the beginning there's 11 marbles in there. And then when you pick your next marble, now there's only 10 left. So the probabilities on the branches change there. And there's 2 branches that have the probability of red. Don't look at the highlighting ones there, but you could get, sorry, there's only 1 branch to get both reds, and that's the bottom one. And that would be 6 out of 11 times 5 out of 10. And that might be something you could do without having to do the tree diagram. You could just think about it and say, I have to get a red one first, and I have to get a red one second. The tree diagram is nice if you're thinking about part B. At least 1 green marble was chosen, because then there are those 3 highlighted branches. You could either get both green, get a green one first, then a red one, or a red one first and then a green one. And if you add all of those branches up, you'll get 8 out of 11. If you wanted to do less math,
couldn't you just do 1 minus the probability?
yes. So doing less math would just be 1 minus what you found out in part A. Since 3 out of 11 are both red, the opposite of both red would be at least 1 green. And then that would be 8 out of 11. So that is a much quicker way of doing this. And whenever you see that at least, that'll be a hint that you can probably do it that quicker way. And look at the complement and subtract from 100%. So I don't know if some of you got started on an example 4. Here, we can set up our diagram. It says that each shot is independent from the last one. So if he hits, he doesn't necessarily get better. If he practices more, he stays the same all the way through. So the fact that it's independent means that in our second set of our tree diagram, those percentages of 0.8 and 0.2 stay the same. 2 bullseyes would be a hit and a hit. One bullseye would be 2 cases. And at least one bullseye probably makes sense to do 1 minus both misses.